And underneath that, really for the end-to-end projects, also to integrate them into the customers or to the organizations, from the data management, data warehousing, or new digital decoupled data lakes, enriched with next generation BI and forecasting models to the end, really to the user, to empower them to use the possibilities of analytics and artificial intelligence. And so our main topic is really to transform the organization, and we are vendor agnostic, so we are not a software company like other competitors of ours are. We have partnerships with most of the large software companies, and are really selecting the best, or the best fitting part for the regarding client. Might it be on-premise, might it be cloud-based, open source or not. We have the whole portfolio in our capabilities. On the right side, you also see some of the clients in the region where we are working and doing large applied intelligence or data science projects. But I will not bother you further with let's say name dropping and credentials. And I'm also quite keen to hear the two talks in this first ViennaR meetup. So with that, I would give back to Mario, or directly to Vaseef as the first presenter.
So thank you, Albert. As you mentioned, we are really keen on hearing the talks. First one is by Dr. Vaseef Massoud, lead data scientist at Magenta. And I'm just searching his name to unmute him. Unfortunately, I cannot find him. So could you, Vaseef, could you please identify yourself? I just, based on the name, I cannot really find you. Albert, do you know who it is? Oh, he seems to have connection problems. So in that case, maybe we
could switch to Felix in the beginning.
Could switch to Felix. So Felix, we're just changing now the schedule. I'm unmuting you, and maybe it would be possible that you start with your talk first. Hello.
Of course. So can you hear me?
Hi. Yes, perfectly.
Perfect. So I'm very bad in waiting, so I'm very keen on starting here as well. So no worries at all. I'm pretty sure that in the next 30 minutes, Vaseef will get the possibility to connect, and then he can hold his talk. So before I introduce myself, I will share my desktop because I have prepared some information and slides for you. So let me just check this. Okay. So do you see my screen? Okay, thank you. Thank you for the answers. So let's start here. As our country lead, Albert just introduced our company before. We are delivering data science projects. Before I come to the topic of today, which is anomaly detection, a very exciting topic, by the way, and the end-to-end process we designed, I shortly want to introduce myself. So my name is Felix Glaser, as mentioned before, and also as you can read here. I am data scientist at Accenture, and I started in 2018, so it's 2 years now. I have background in mathematics and statistics, so I studied at the Technical University of Vienna. And there I got in touch with R as a coding language because it's very common for statistical programming and forecasting and econometrics and things like that. So this raised my desire to invest more in R developing, and Accenture gave me the chance to still, increase my skills in this field. And this, so, okay, this is not working. Okay, now it's working. Perfect. This directly brings me to my first point on the agenda for the reason how we do data science. So the question is actually why R, and is it only R? I have some good reasons here on this on the screen. So why do we work with R when it comes to data science and when it comes to machine learning and topics like that? A very central point is that R is open source, and this gives us the opportunity as a consulting company to do, for instance, so I got the, okay, to do prototyping, to show our clients what actually R is capable of and what their data is capable of. So what data science can actually do. And therefore R is of course very good in place as it is open source. So we can really do fast prototyping and things like that. And we are very flexible when it comes to fit into IT landscapes of clients, for instance. The second point is also a very important one, and it played also a key role in the project you're going to see later. The scientific contributors. So R is very, it's used in many departments of many universities all over the world, and this gives R a very strong scientific background. So many data science problems are very, very difficult and very, very hard to solve. So the solutions are very sophisticated in many cases. And therefore it could be useful to have scientific background, scientific papers where R packages are derived from. So that's a very big plus point here. And last but not least, and this goes in hand with the scientific contributors and the the usage of R at universities all over the world, is the widespread skill. So R has a very big market share, and this gives companies, for instance, like Accenture, but also many other big companies, the possibility to find skilled R developers. So a skilled workforce gives you the possibility to solve problems with a certain coding language. But Mario told me that the question or the topic R versus Python bumps up very often. So I also want to mention here, we are of course not only using R. There is also, for instance, Python in place. So in many topics within data science, there are R solutions, there are Python solutions, and there is actually not a R versus Python. It's more, I think, a R and Python. So what we try to do is using best out of both worlds to deliver just solutions which are best for our clients. So that is my answer in this case. But in this case, or in the today's topic, we deliver the solution with R, and that's the reason why I'm sitting here. So let's just come to the topic now. Anomaly detection and an end-to-end solution with R. So before we jump into the machine learning and data science part, I want to give you a feeling what the problem was that our client faced. So the client is an insurance provider, and the insurance provider wants to need support in detecting outliers in the customer base, to detect them and giving them optimal recommendation. So this is actually the topic. So the client wants to service the customers in the best way, but as the customer base of the client is growing from year to year, And the process of making these recommendations and things like that, so the best products and the best programs to get healthy again, is a very time-consuming one. And of course, the resources are limited on the client side. And intelligent solution is maybe a very good thing to think about in this case. And the third point mentioned on the current situation is the so-called 360-degree view. So when you want to rate anything, yeah, you just need to check all the data around. And in this case, if you want to find or if you want to rate a data point as a customer, or if you want to find an optimal recommendation, you need to check all the data which you actually have to generate this view around the customer. And this is very hard to do not with an intelligent solution, because for case managers, checking all the data of every single customer is just way too time consuming. So this is the current situation. And in the same way, our client had also some main goals and also some visions. So first point is, as already mentioned, the optimal recommendation. So this is the vision the client has, getting the optimal recommendations for cost-effective long-term health. That's the term here. And before you can make these recommendations, you need to detect the customers which need recommendations. And this is the central point of our project. Ethical standards. This is an important thing always when it comes to data science or to artificial intelligence. So we had many bad examples in this case all over the world, also in Austria and also in Germany, for instance. So what we have to consider as data scientists and what we have to take care of to avoid any type of racial bias, of gender bias, of geographic bias and things like that. So we really have to take care which features we are using and what their influence is. And the third point is the so-called explainable AI. So for us as data scientists or as machine learning developers, we may be capable of understanding the outcome of an algorithm or understanding the numbers out of a model, but our clients maybe do not have the same skills and do not have the same possibility to understand this. So we have to make sure that our clients understand and trust the solutions we are delivering. So that's also a very, very central point here. So when we tackle projects and we tackle problems, of course, we have a very structured approach on this. And before we come to all the super interesting data science part, there has to be done some work before. So analysis of a current situation, it's super important to understand the client, to understand the problem, to understand the processes, and to evaluate all this in close collaboration with the client is the fundament of a successful project. But when this is done, we can step to the data science part, so to the coding part. And before we start coding, we always should actually make sure that Git is in place. So I'm pretty sure that most of you know what Git is, and most of you maybe also use it in the work, also at university. But I just wanted to mention it here that Git is super necessary for version control and for team collaboration. And the main reason why I'm mentioning it here, RStudio also delivers a Git add-on, which is very user-friendly, so you can very easily track your projects within R. You can do version control with Git via RStudio. And yeah, this is just a very important point I wanted to mention here. So but now we come to the modeling part. But before we can estimate a model, we need actually a database for the model and for the modeling part. So you see an very famous Accenture intern word in here, the so-called customer analytical record. So what is that? This is just aggregated data which gives us, as far as possible, this 360-degree view around the customer. So this is just a collection of attributes which describe a customer. So in our case, we had around 300 or maybe a little bit more. But I want to show you more in detail what this customer analytical record actually looks like, to give you a little bit more feeling of that. So let's just shorten it with CAR. This is way shorter than customer analytical record. This is actually, in this case, a very big table with many rows, where every row is a customer and every column is an attribute. So we want to describe a customer with many different attributes, so that we come as close to this view around the customer. And I have some examples here, some different attribute groups. So for instance, we collected demographic data, insurance data, product data, interaction data. So every group again has some attributes in it. For instance, the frequency of interactions, the frequency of complaints, or maybe also the age and the profession, and many things like that. And to get all this data in place, I've listed you some interesting R packages we used to develop this. So RODBC, for instance, is a package to get the data from databases. In our case, it was an SQL database, to RStudio, where you can then take the raw data and with, for instance, Tibble and also dplyr and also Lubridate, you can just do all the data wrangling, the data manipulation, and the data aggregation to get this table out of all the raw data. DevTools is always important when you have bigger R projects where you maybe want to create your own R package. That's what we did in this case, for instance. And Futile Logger is a package where you can easily create logging structure within your project, so that you can, for instance, easily debug when your code is crashing, and that you easily find, for instance, the position where it crashed, or maybe the reason where it crashed. So as we have our database now, we can step towards the modeling part. You see some packages again, which also have been on the page before, for instance, DevTools and also dplyr. But also ggplot is very important in this case, because visualizing the results of your model, for instance, is a very central point to take this into client discussion, and also for your own understanding of a model outcome. And a central package is the so-called ROS PCA package, but this I will mention just in a minute. But before, I want to talk about this AI engine again. So something important here is that we had no label, which means we didn't know what has been an outlaying point in the past and which not. So we could not take the approach of supervised learning, and we had to step towards unsupervised learning. So we tried different algorithms. In this case, we did research. We did different clustering algorithms, for instance, density-based clustering. We did principal component analysis in many different ways, especially robust PCA, but this will come on the next slide. Before I come to that, I want to shortly explain what PCA actually is. So I think many of you know what PCA is, but just to give this 30 seconds. PCA, principal component analysis, is a mathematical method to reduce the dimension of a very big vector space. So you want to reduce dimension without losing too much information, without losing too much of the variance of your original data set. So just reducing to a small amount of dimensions and keeping the most important part of it. The thing is, so PCA is nice because we have a lot of, a very high number of dimensions, a lot of attributes. So we want to reduce it to also, of course, make the code faster, make the prediction faster. But the normal PCA has a problem. So just let's focus on the picture on the right side now. Picture A shows us the typical PCA picture from the slide before. But what happens if we add some outlaying data points? So you see the red dots in picture number B. A typical PCA immediately starts to turn, to move, to react very sensitive and react immediately on the outlaying points. So this is maybe not the best approach if you want to actually detect those outlayers. So you need a robust version. And in the lower left corner, and don't worry if you are not fast enough to write down the name of the paper, because I think the slide's going to be published afterwards. In the upper left corner, you see a paper where an approach is derived to get a version of a robust principal components, a robust PCA. So this paper is not just only very interesting from the content, there is also an R package in place, this ROS PCA package, which has included the algorithm which is derived in this paper. So I want to show you why this robust PCA is important or just was successful in our outlaying detection case. Just take a look to the right half of the slide now. So we have, for instance, an input picture, which is a digit 4 in this case, and we describe this with 4,000 dimensions. Then we reduce it to a smaller vector space, dimension 50, and then we can again project this in the original space. And if we compare the input and the output, we see, okay, we lose some information, but we keep the most important information to still be capable of understanding the output, understanding the data. But what can we derive from this method? We can derive 2 very important distance measures. And those distance measures are very central in classifying data points as outlaying points or not. So the orthogonal distance is the distance between a certain data point and its learned representation. So input minus output. And the score distance is the distance between the reduced representation, so the red one, and its center. So those 2 measures are in place now for describing data points if they are outliers or not. Now some more information about the package we used. So in the upper right corner, you have the link to the R package and also to the description. So you can check all the functions which are included there, also with links to the scientific papers. So we used some very central functions of this package. RobPCA, this is the method where you can just derive this PCA by handing over a data set. So you get back the eigenvectors, the eigenvalues, the loadings, and also the distance measures I described on the page before. And the ROS PCA is just an extension of that. I wanted to mention it here. It is the same as RobPCA, just with the extension of sparsity. So this is just another step, another approach in the way of robust PCA. And diag plot, of course, is important to generate diagnostic plots about your model to understand what your model actually is about. But this was not enough in our case. And the nice thing is that we just could check the source code of the package. We could understand how it was actually developed, and we extended it to our needs or to our client needs. So first of all, what you need when it comes to modeling or when it comes to machine learning, you need a prediction function, because you have a training file, you train a model, and then you want to predict a testing data point to test your model. So we created a prediction function which takes a model and a data point and makes the prediction, which is the distance measures, to derive from this if a point is an outlier or not. Calc importance. This is now another aspect. So we wanted to also derive the information why our model made a certain decision. Yeah. So we took the distance measures, and from the distance measures, we could derive which attributes contributed to a high distance measure. And this we ranked and listed in this calc importance function. So we got back just a list with the ranked feature importance. The plot engine is just an extension of the plotting version of the package, because we wanted to also use ggplot for deeper visual insights. And also very important when it comes to modeling, you need maybe a function to compare models. So from time to time, we got small labeled data sets from the client, which was very helpful, of course, to know where your model is actually, how well your model is behaving. But you, of course, need a comparing function. So a function which is taking two models and a data set, and you just see how the data set is doing in model A compared to model B. And last but not least, the classified traffic light function. So I mentioned it in the beginning, the explainable AI part is very central. So of course, we could just send distance measures to our client and just letting them interpret these numbers. But it's way better to find a solution which the client can handle. So we thought about, okay, why not putting the solution in a traffic light with red, yellow, and green light, just if the point is an outlier, intermediate, or not an outlier. So we derived these traffic light borders in an iterative cycle and also with statistical methods. So maybe we have some time to discuss this afterwards, but I would jump now to the last part of our approach. We have now a database, we have our model, and now we have to lift all this into production. So when it comes to production, there are many central packages, for instance, testthat. So with testthat, you can just you can code tests in R, and as soon as you make, for instance, changes in your code, you immediately can test if your code is still running in the way you want it to run. Furthermore, logging, again, very important dev tools for developing packages. Lubritate, because we are using live data with timestamps and things like that. RODBC, because in the production case, we needed to also make data pipelines to databases. You're gonna see this on the next slide. And very centrally here, Plumber. Plumber is an R package to develop web services. So we developed an REST API, getting a JSON and sending a JSON back, interacting with the client's front end. Okay. So now for you to understand all this end-to-end process, I have now a small animation to give you a feeling how this really looks like and where data is handled from which point to the other. So we start with the front end. So a case manager is working, using the front end, checking customers, and then pressing the predict button for a certain customer. As soon as this happens, live data gets extracted out of the front end and gets put into a JSON file. And this JSON file is sent to a web service which is running on a server. The web service, takes the JSON, takes the identification number, for instance. And with this ID number, the web service just with our ODBC takes data out of the custom analytical record, so the historical data, because the live data is data from the front end, which is not in the database yet. Yeah. So we also need to take this historical data. And this car is also scheduled on a server, running every week, refreshing every week with new historical data. Yeah. So this this historical data and this live data gets combined in the web service, and in this web service there is also the raw PCA model. So and this raw PCA model includes also many of the functions you have seen on the slide before, and now many of those functions are triggered. So first of all, the prediction function. Yeah. So we take this data, we predict now the distance measures. The next step is the calc importance. So we want to derive the importance from the distance measures. And the third point is that we want to also derive the traffic light. So red, yellow, or green. All this information gets packed in a JSON file, and this is sent back to the front end. So the client sees red, green, or yellow and has a reasoning for the result. So this seems pretty done now, but it's not, because we missed a very important part here, the feedback loop. So in machine learning, it's always important collecting feedback to the outcome of your model. So we also implemented in the front end that the case manager can just give feedback on the traffic light and can give feedback on the reasoning, so that we know how our model is doing, if it's doing well. So it's kind of monitoring, but also maybe for future steps, if we want to approach semi-supervised learning or supervised learning, for instance. So that is actually my, that was my case to present. I hope you enjoyed it. I hope we have some questions. I have seen that there are some messages. I think we could just start with the discussion now. I hope you enjoyed it. Thank you a lot. Okay. Can you hear me? Okay. Are there any questions? I'm just checking now. From start to end, how much time did it take to complete this project? So that's a good question. The production period took around, let me re-estimate. This is was around 4 to 5 months to deliver this project. So now I lost the chat because I'm not sharing it anymore. Do I also have to take a PCA approach or also an experience-based selection like I do for internal rating systems? Not really sure what this question is about. Maybe the person can just get unmuted to discuss this if we have time. Mario, I cannot hear you. I think you are muted. Sorry.
Hello, can you hear me now?
Yeah, now I can hear you.
Okay, I'm sorry. Somehow my microphone got lost. I don't know.
No worries, no worries.
Yeah, technical issues for the first online meetup. So the question was from Asaru, I think.
Yes.
And wait a sec. So Asaru, would you like to ask the question again to Felix to clarify?
Or was it already answered in the chat?
I'm not sure. Asaru, would you like to talk? Okay. No, it doesn't seem so.
Okay, maybe we can just, I think I can text also. I can text him here in the session, so maybe we can discuss this out. This is okay.
Okay.
Any other questions? do agents press the predict button in each case? Wouldn't it be better to automatically get the prediction? And do agents give feedback all the time or not? Okay, that's a very interesting, that's a very good question actually. So no, they do not always press the predict button. They can press the predict button. And if it would be better to do it automatically, this is maybe right. We had here some restrictions because we had to fit an existing process. So it is not easy to bring a machine learning solution in place and immediately make automation, you know? So first of all, before to make this automation, the case managers and overall the client has to get trust in all this. But the point you are mentioning is of course a very good one, yeah? And do agents give feedback all the time or not? So, so if they use the predict button, they also give feedback on that. Because this is a very important point, especially in the beginning of this project, to just see how the model is behaving and to collect this feedback for future opportunities.
Okay, have you already answered the question how long the project took?
I answered this. Yeah, I think maybe you didn't hear it, or I just answer it again.
Okay,
it took around 4 to 5 months to bring it in production. Yeah.
Okay.
Okay.
Okay. If you have any more questions, please, again, you can use the chat, or maybe you can also ask Felix directly. So
exactly.
Maybe you could also show your email address so that people can contact you for more questions. The slides are online. You can also see them on the Meetup page, or I also posted them to the chat. So please use that. So again, thank you very much, Felix, for your great talk. I saw lots of interesting questions, and yeah, see you soon. Hopefully not only at home.
Hopefully. So just once again, if there are any questions, just text me here in this texting window, or on the slides you have my LinkedIn link and my email address. So just reach out to me. I would like to have open discussion about this very exciting topic actually. So thank you again very much for having the stage here.
So perfect, thank you. And so we will now switch to the next talk from Dr. Vaseem Massoud, lead data scientist at Magenta Telecom. He will talk about smart churn retention. And I will now also post the slides, the link to the slides to the chat. And I hope Vaseem is now already online. Vaseem, I'm now unmuting you. The stage is yours, and we're happy to hear you talk.
Thank you very much. Hi, everybody. Should I have to share my screen, or do I use your slide, or how actually?
Please share your screen.
Okay. Can you see my screen now?
Yes. Perfect.
All right, great. Yeah. Hi, everybody. My name is Vaseem. Actually, sorry, I had some I was actually in a different conference and trying to figure out why nobody's there. So sorry for being late. So my name is Vaseem Massoud. Actually, I work as a lead data scientist at Magenta. It's formerly known as T-Mobile. And working there as quite some time already, almost 3 years actually. So we have developed quite a lot of data science related use cases regarding our demand requirement. And one of this, what I'm going to present today now actually is about threat propensity model. It's actually a bit of a geekish. I mean, I'm not really much familiar with the setup of the meetup. So I usually am not. It's my first time actually attending any meetup. So if it's a bit more of a more theoretical is going in the direction, just please pardon me for that. But I just wanted to actually touch certain points over here to give you a broader prospect actually that about not only about R, but actually what are the possibilities really out there actually to achieve something. But certainly, of course, with the strengths of R in it. So if this entire actually talk, I divide into 4 main parts actually. One is just first is about the general introduction. what a churn model looks like and what are the challenges and what is actually the life cycle, how you start it and how you end it. And then actually go deep down into 3 further sub parts to explain actually what exactly is inside these parts and how do we really need them. It's actually quite a thorough topic, but let me try to finish that in 30 minutes. I will try to actually be as productive as possible. So in this slide, actually, you will also find actually some references on top. If I can just use my mouse, I like actually this is the point. Yeah. So these are usually the references from scientific research papers that I was actually putting here. So at the end, you can also find those to actually read things by yourself. So what is a churn model basically? Churn model is that we really need to understand that how our customers are feeling and what is their propensity to churn. So I mean, how likely are they going to leave our contract? This is basically a churn model. I mean, a churn model is a very comprehensive topic basically, and it is one of the core use cases of any business. So if you look at the life cycle of a churn model, you usually start by identifying the churn triggers. This is basically the first thing, which you so to call actually what data do you really need to work on. And here is a lot of research over there. And if you, I mean, they are specifically talking from different disciplines, and also they're talking about telecom in specific as well. Telecom has a very interesting problem because it has the customer structure. The structure of the data looks a bit different. So to say that we have actually a customer, then the customer could have multiple contracts. So it's actually becomes a bit more, it's a hierarchical structure. So it's become a challenging problem in that sense, is that which granularity are you going to measure the churn propensity? And then how is going to eventually accumulate at the customer level? So this is one of the challenges there. Modeling, we know there are plenty of models out there. So second option is that once you identify the data, what model exactly are you going to use? Because I mean, in telecom, the churn is highly imbalanced classes. So you really don't actually know that, and then you have to accordingly choose the algorithm if the balance class is at that high, because the churn is only 2% and the customer base is, I think, around, I mean, 4 million, something like that. So you can imagine that how rare this event is to identify. Then, of course, we have this topic called hyperparameter optimization. It's a research discipline in its own self. I will going to try to show you actually what are the practical aspects we have used here. Then we have the context analysis. This is also one of the very interesting part. Actually, just having the probability is actually not enough. We need to understand what are the factors actually which are leading the customer to churn, so that we can improve our business accordingly. At the end of the day, actually, eventually at the end, you have to do the out of sample validation. Out of sample validation means that you have been running 10 months or 6 months or whatever, and how good are you performing? In general, there is a lot of research exists out there. So I'm just putting you actually this one recent work that's not really recent, but actually this one work which has been done actually to understand different disciplines. And they actually have this one very interesting point over there, is that usually there are very many factors that affect the customer, which we cannot observe, like marketing factors, like for example, market dynamics. As you can see at the moment now, COVID-19 is one example. That how these external factors change the market and how actually things are going to change, and accordingly your models become obsolete. So it's very important that you really stay on top of these things. Churn triggers. So actually there is, as I mentioned, is one very first step actually to build the churn model is a churn trigger basically. And there's a lot of research out there. If you read the research paper, then there is somehow all of them collectively summarize these triggers into the like, for example, in these main categories. If you look here, I mean, there are just the basic ones I'm mentioning over here. So there is demographics, cost, actually how much customer is paying, the tariff detail, what exactly the customer has, for example, and then the sales channels. A lot of different things actually really affect the customer churn. For example, if a sales channel is good, then basically, which means that the customer, if they provide you good after sales service, which means that if something is sold from that channel, it has not much, it has less probability to being churn prone. And then we have some other aspects over here about usage behavior, how often how much the data is used and how much the roaming is used, and how many times the calls have been made, and then of course the customer service, how many times the customer tried to call us, what were the problems you were trying to address with us, was the problem resolved or not. Another interesting one actually is network quality. It's actually one of if you look at these 3 points that I mentioned over here, basically, they are very thorough research areas in themselves. So if you want to get anything, the fun part of that, you do a lot of work for 6-7 months on each of these topics, and you get one number out of it. And that one number basically you use to basically then go further to predict your churn. So that's how complex the problem is. I mean, network quality is a very interesting topic in itself. If you are really interested, actually, there is a talk I gave on Cloudera Data Summit in Barcelona 2019, where we also won the best data science work of 2019 award as well. So I was not able to find it in the archives, but if you might be able to find in the archives, it would be interesting to just go and have a look at it. How does network quality can be measured? Network quality is basically a simple thing: is that how much the customer is paying, and I mean, what is the service you have? Like, what is the throughput? What is the latency? These kind of things that's in there. So what we actually did is that we had designed a churn model, which is we are trying to actually using that we are predicting the score of an individual customer to churn, and the target variable is that to optimize. We have used it initially. We have used the first attempt basically we did was with R. R is a very powerful tool in the sense that it gives you a very it has a first of all very extensive set of libraries. So I mean, I think this is the tool which has the most extensive set of libraries. Anything that comes out in the market, most of the research papers you can find, actually, even very interestingly, I was reading one research paper. I think the previous talk they would also mention that every second or third latest research paper you read from 2019, for example, so to say, you're going to find a library implemented that in R. That's actually one of the very useful, very strong sides of R. There's some packages I have mentioned over here because this particular algorithm was based on deep neural network. So you're going to find, for example, Caret over here. It was used. Keras was used, and Caret was used actually as well. Caret is usually for hyperparameter optimization. You can use that. Yardstick is. These are the libraries and packages which are very interesting to use to give you the idea that how you can play with the data, and once you have the result out, how to better present them and things like that. There is also very interesting word called Lime. Basically, Lime is actually helps you to interpret the results of the network of a model of a deep neural network model, or if you have a further on top, if you, for example, have anything else over there. We have basically, so this is typical structure look like. You have the training set input that goes, you train the model, and you have certain set of hidden layers in between, and then you actually have an output score. There are different KPIs based on which you measure the performance of the metrics, the performance of the algorithm. You have the typical called confusion metrics. And then on top, you actually have several other kind of metrics, which are mostly deduced from here. And there are some interesting metrics, for example, top decile lift. I will explain you that in a couple of minutes. So the thing is that once the evaluation, actually what you really see also online in different I don't know, blogs and different books. This is basically very thoroughly used as well in industry by us, so to say. So relatively boring slide, just give you an idea actually how the code actually looks like for setting up a deep NN model actually in R. So quite very simple. You have the code to actually build the model. So here you are doing the model definition. You are defining some layers, some functions, some units, and then you also optimization your strategy for gradient descent, and then you have the metrics which you're optimizing, and then then there is something called in the execution of for monitoring of your algorithm. There are actually got some interesting points, the checkpoints and early stopping condition. Checkpoint is like after every iteration, you save your model because you never know when your machine is going to break. And that really happens quite frequently in practice because the data is massive. And then you have basic early stopping condition is a very interesting condition. I notice that most of the people don't use it. Early stopping condition is that you tell your algorithm that stop training after X amount of if your improvement, if the loss has not improved for, I don't know, for 50 iterations, or this patience is one parameter that's used over there. So this is just an example. You can actually see that, and when you run that, you're going to find actually a simple example that you can really test it at home for yourself. Now let's go to a bit of a geeky part. Actually, this is called hyperparameter optimization. So what do we have? We have a huge set. So one of the challenges with machine learning models is basically that they have these hyperparameters which you cannot identify, which the algorithm does not help you to identify. So you have to define them, like so to say, manually. So you have to adjust them yourself. And depending upon the hyperparameters, your performance really fluctuates. It's unbelievable to see actually that how, I mean, your accuracy could be really very, very horrible if you just wrongly identify these parameters. Now, if we, what basically, so what do? We have different methods to do hyperparameter optimization. We usually hear this called grid search. The grid search is that you take all the possible combinations of the hyperparameters and you use them to train your model. So in a neural network, how hyperparameter is a huge set. Actually, you have the learning rate over there. You have number of neurons. You have the activation functions. You have number of layers, and this all number of layers can grow as much as they can grow. And in that particular case, so you really need to understand that this is a very, I mean, it's just the problem. Complexity grows exponentially. So what do we need to do now? So what we need to actually, the normal method is like the grid search, where you get all possible combinations and test them. Then you have a random search. Random search is basically you randomly look between the parameter hyperparameter settings, and eventually it is basically there is a research paper on that where they claim actually is that if you approach random, if you use random method, is actually as good as a grid search, but it's certainly way more less than the grid search. But then they have their other challenges. I mean, the good thing is that you can parallelize that, but still you need a lot number of parameters to test that. A total different approach from these two approaches is called Bayesian parameter optimization. The Bayesian parameter optimization is just telling you that since every time we change hyperparameters, we have to retrain the entire algorithm. Bayesian approach gives you a solution to that. What Bayesian approach is doing is that it says that you set a few set of parameters, and based on those few set of parameters, you measure your accuracy. And then from that, based on your actual objective function, you define they call something called a surrogate function. A surrogate function is a kind of function which can mimic your actual function, but it is way more easy in terms of, it's more cheap to evaluate. So a surrogate function, a typical example of a surrogate function is Gaussian processes. And then once you have, so what you do basically is that you use, instead of rerunning your entire, your actual function, your actual objective function, you kind of you use this Gaussian process. What it does is that it do some resampling and gives you out somehow a space where you should actually go and search for your hyperparameters. What I really mean is basically, I mean, this is a very simple explanation of this particular algorithm. So what do we usually do? We have a function, which is our function, like function that is coming from a deep neural network. This is the data we are using, and S is basically this kind of a surrogate function. As I mentioned, a surrogate function, S is basically the acquisition function. Just while you explain you what is the difference between an acquisition function and a surrogate function. So what you usually do is that you train your model and you get some data out from that. From that particular data, what you get, the results, what you have now, your set of hyperparameters, and that set of hyperparameters give you a result. Using this set of hyperparameters, what you do, you try to figure out what exactly is the direction where I should find a next hyperparameter which will improve my accuracy. So if you look at here, this is example, this entire thing summarized over here. What you have basically, you have 3 points or 4 points. In the beginning, you can consider like these 4 points you have. What you did actually, you train your model on these 4 points, and these points are basically, so I'm presenting you in a one-dimensional space, but you know there are many dimensions of the parameters. Consider just this is a learning rate, for example. So learning rate, you tested 4 times, and you have the output of the algorithm. You can consider that the accuracy was like this. Y-axis is the accuracy. So for this particular value of parameter, you get that much accuracy, and accordingly like that. What is Bayesian approach is telling you is that it's trying to figure out that within these 4 points, where should you go? This is what this Bayesian approach is telling you. What does the grid optimization, grid search telling you? Look each and every point one by one, and eventually go through all this curve. What we need to, we need to maximize this function, whatever this function basically is, or we can also say minimize the function, depending on what you're doing over there. in this particular example, what we need to have, we need to find this point. So there are 2 points of it. One is this Gaussian, what I call is the surrogate function. The other is basically the acquisition function. And this is exactly what acquisition function is telling you, that which direction you need to go. The Gaussian process is basically asking you that, helping you. But Gaussian process is giving you another point that you need, that the possible you need to search, and then the expected the acquisition function is telling you which direction you need to take the point. For example, in between here, you can see the uncertainty is very small because you exactly know what is the functional, what is the behavior of your model for this hyperparameter. You also know exactly what was the behavior of your model when you had these values. But in between, you don't know. So you see these small lines are basically the variance of that. So it's a huge variance in between. So here you can search, here you can search, or here you can search. And this is exactly told you by this expectation improvement function. Expectation improvement function is a type of acquisition function. There are many acquisition functions you can actually use, and then this is how basically you are trying to optimize. You are trying to figure out which direction you need to move. So, for example, here the value of this function of this expected improvement is 0 because you already know where you are. So these points are exactly, and in between, this is showing you that there is a possibility that you should look into it. But then you compare these 2 peaks with this peak, and you saw, okay, this is the way that I should go because this is the direction where it looks like that there is something more happening here. And then you can actually see that the best point lies over here. So this is basically the idea. It's a very extensive topic. You can actually just use any library to actually use this. I mean, there's a lot in R you can use that. I mean, you can find built-in libraries, but I was just trying to give you some idea, some glimpse of it. But this is actually something that really is very important and helps you a lot in improving your algorithm, in improving the accuracy. So, but here's another point, basically, that all these methods, these Bayesian optimization has some hyperparameters of itself as well. So, for example, there are many acquisition functions you can use. I'm showing you one example of it. So, which one should you use? Then within the Gaussian, for example, then you have different type of kernels actually, and some other parameters of Gaussian that you should use. So, there actually is this what is then again become a question that then you need hyperparameters to tune your hyperparameter. So this is one point over here. So in general, it really helps a lot. I mean, usually, for example, in my experience, the code was running. I mean, you really need to let it run because it's not automatically going to converge. So that's why you can actually see that the iteration, the loop has a breakpoint over here, and you kind of run for, I don't know, for in our case, I had this running for weeks. And after 2 or 3 weeks, it's converged, and it has really improved the accuracy in quite some amount. So this is something that's very important and recommendable. Here is this particular slide actually just giving you an idea that how usually these accuracies and how do you really measure how good the model is doing. So you have, for example, the outcome of your model in current point in time. For example, for 1 month, you can compare it. And you can also compare it in 3 months, how good you were doing. And then you can also compare it with 6 months, how good you are doing. Technically, the longer the time you got, the better you should go, because eventually that customer should churn. And if it's not happening, then you are in bad luck. And within the one thing you need to do first is do a random comparison. So which means that if you randomly choose a customer to say whether it's churn or not churn, and compare it with your algorithm should be better than that. So for example, and then you can further use different deciles to further identify that in which decile you're really good and which decile you're not good. And eventually you can actually, at the end of the day, you can see actually how good you are. You're 3% better than, in this particular case, for 70% probability, you're 3% better than, 3 times better than the random guess. And here you're basically 4 to 5 times better than the random guess. So just get you an idea, basically, that what is there. It's kind of a bit of a heavy slide here. So churn is basically a model. The problem, as I mentioned, is very commonly used in industry, right? And then here is a very interesting couple of research papers. Actually, they look in a different areas. They did this type of study, which is published online, and then they try to compare their accuracy with each other. We have these 2 models basically that we developed a couple of years ago. You can actually see there. So this is the unit over here is called the top decile lift score, which means that in what decile you had the best performance. For example, you had when we talk in the previous slide, like this is a decile, for example, like everybody who has a score greater than 80%, how good were you identifying them? So this is an uplift basically from compared to the random search. So you can see that a lot of algorithms over here mentioned, and there were 13 netcode operators they use and 21 different techniques to compare all of that. So if you are working on that, you can have your own comparison over here. And then there are different things basically you can do as benchmark. You can really add, you can do feature engineering. It's one of the most important. You can see you can improve your accuracy by 22%. Then you have a modeling technique itself. For example, there's one thing called oversampling. As I mentioned, that this is a highly imbalanced problem. So what do? You try to oversample the undersample events, and that's how you somehow come up with the comparison here. Then you have the model in operation. You really need to continuously deploy it. You really need to test it. You should develop some dashboards, how to show you how the model is doing, and accordingly you should always have to update your marketing colleagues or anybody who is your stakeholder to tell them whether the algorithm is still valid, it's not obsolete. So it's still doing valuable predictions rather than you just go around and do random search over there. The next point is actually very interesting as well. It's called context analysis. So what I mentioned before is that just measuring churn probability is really not enough at all. It just tells you that, okay, there is something wrong, but I mean, you can have as many possibilities, as many input variables you have. What you really need to do is that you need to identify what actually were the problems that are creating that we need to improve, for example, right? And one example is that if a lot of time as a trigger, the network quality is appearing, that you know that you have a shitty network. So this is an example. And how do you know that? So usually if you look at these models, they're black box models. And that's why actually the Gaussian process also works very well on the black box model. That's why you use a Gaussian process, because it's non-parametric and it actually kind of approximate any arbitrary complex function. So what is actually, so there are many approaches over here how to deal with this kind of issue. So it was very interesting and very kind of relatively latest approach from I think 2017 or something called Shapley values. So what is basically Shapley value? So what do you usually do now? What you need to do actually, you need to identify that what is the impact of individual KPIs or of individual factors on the customer to churn. And this actually concept is coming from, we call that the cooperative game theory. Game theory is itself a very rehearsed topic. There have been several Nobel Prizes on that, when the game theory is used basically in economics. I mean, game theory is a mathematics, the discipline of mathematics, but I'm not really sure it's mathematics or computer science, but anyway. But yeah, and there actually it's used quite a lot in other disciplines, but here is actually also used. So yet come another value of it. So what is all these things? What I wrote over here is what is this telling us? It's just telling us that imagine that you have a team of 5 players, and what do? You need to identify, and collectively these 5 players are basically playing the game. But what you want to do, you need to identify what is the value. We call it payoff. I think the word is actually mentioned over here, is defined by the for the action. So we call it the contribution each player is bringing to the game. It's called payoff. So this is the entire thing, and you can actually use and map this approach exactly to identify your black box model, which means that you can replace your player definition with your attributes. So which means that if I have a model, it has 12 parameters in it. One by one, I replace one parameter and I add another parameter, and I see how my accuracy is improved. Then I drop that parameter and add that parameter, and then I see how my accuracy is improved. And in this particular case, you're going to find that you have so many combinations, as many as you have players in the game, and as many, and from these many players in the game, you can make that many amount of small subset of the collations. For example, if you have 5 players, so you start with 1, and then with this one, you try this one and try adding all other 4s one by one to it. And eventually you find one guy who's added over there. So now you have 2 players of 2 teams. team of 2 players. And then what you do, you add a third guy. Then from out of these remaining 3, you try to add one by one another player. And then you see how these things basically improving. And then at the end of the day, you get a Shapley value, which is basically a contribution of individual player. So this entire equation is just telling you this is that you have a current function. Current function means this function is basically what your algorithm is. Your deep neural network algorithm is this function. You test this deep algorithm without one parameter, and then also test it with one parameter, with that parameter which you removed. And you take a difference of that, and you see how much eventually your objective has been, the loss has been reduced, or loss has been improved. And iteratively find all possible combinations of all possible such combinations. This is basically the idea. How does it look like in practice? That's how it looks like. It's a very interesting thing called force plot. What does force plot tell you? Look at this way. The Shapley values, as you can see, it has a very thorough mathematical background. So you can basically, it has a, so you in a lot of forms, you can actually use it in this capacity that you have a thorough mathematical background for that. What does it tell you? This force plot, it has 2 interesting things. One thing is called base value. Base value is basically, it tells you that one particular, for example, customer, you can say in this particular case, that this is the average score of all the customers you had. This is the base value. And the output score is basically that score, this particular customer, what his score is. So this is like, this particular customer is almost 1 point away from the entire base. So that's these 2 numbers I tell you. The rest of the numbers are basically giving you the intensity of these individual parameters. This is just a random example I took from internet from the Shapley values original paper. You can also see the tutorial here, actually how to use the Shapley values in R. And here you are actually going to identify them. And then you can see, actually, you see that these factors are trying to push the value towards the base. And these factors are trying to pull his value out of the base, which means that for him, these are the things which are really basically triggering him actually to go away from the average score. So in this case, for example, if you consider, if you are talking about churn probability, that means 100% churn probability, like average has 23% churn probability. This customer has 24% churn probability. And why he is away from the average? Because of these parameters. So this is basically what is actually happening here. And again, a very interesting thing, actually, you can compare it with Lime. Lime is another approach to do the same method, but it's a relatively different background. It has no strong mathematical background, but it is basically work on the simple model that you can explain the things in linear induction form. So one of the very important points, actually, this one is that, this is very fun when you work with these things. One interesting comment, actually, I give you here is that, interestingly, if you can see that as it's including the intensity of the player, it does not include the time aspect of the player. This is very interesting, actually. You can add the player with the same sequence, but depending on what time you add the player is also going to change a lot how the game looks like. Which is to say, is that if you compare this to the actual problem, why I mention is that you have this the event, the sequence of event is very important. But with approach, you don't get the sequence of events. You just know that, okay, A, B, C, and D has happened, and these 3 have turned out to be, for example, most important for him. But in what sequence they happen, if you know that, then it's also give you a lot of help. For example, take an example of the customer churn. Like, for example, consider yourself, you had a bill shock. You pick up a call and you try to approach the call center. You were not able to approach, you were on hold for, I don't know, 2-3 minutes, you hung up. Next day you try again, you were on hold, you hung up. Third day you try, and then eventually you went through, but your problem was not solved. So although you had 2 calls or 3 calls in parallel, consecutively, but then what actually has happened before? Why did you call? What happened during the call? And then what happened afterwards? So this is why the sequence is very important. So that's why I can only identify the time, which is a limitation over here. And if I believe that if anybody of you is actually in research or development, that should be a very cool idea to look into that how you can use time factor into it. But of course, a very complex mathematical problem. So just giving you the idea actually how these things look like. Yep, and this is pretty much what I wanted to present. Here you can actually also find some list of the reference papers that actually I have added over there. I think I'm pretty much done here. If I can, I see there are a lot of questions actually. So I will.
Yeah, thank you, Masood. Thank you very much for your talk. It got a bit over time, but I think it was very interesting, and I'm really appreciating that you took your time and contributed that to our meeting.
I'm sorry, actually.
No worries. So we got actually lots of questions. That
I see them. Yeah.
was actually also the reason why I wanted to really stay on time, because otherwise we don't get through all of them. So the first question was from Abdullah: how did you handle imbalanced data? I think you applied SMODE, right? So I think that should be the answer here.
Yeah, I mean, so quickly answering on that. So usually you can actually try to do oversampling or undersampling. So we tried oversampling.
Okay, using SMODE. So thanks. Roland had a question: how do you use the model and how does it improve the business? And also my additional question is: how did you implement then the final model into your business processes?
Yeah, so the thing is that when you look at these kind of models, so as I mentioned, the churn is, I mean, it's a very rare event. So what we usually do now, how we are using it is that we are giving a probability out, and based on this probability, we identify that which customer you need to approach, because I mean, you have 4 million customers, and then which one do you need to approach basically? And this is how you are using it in actual business. That we tell these numbers come along, and these alarms are generated. For example, this customer has reached I don't know 90% churn probability, so you should approach him. So this is how actually this model is used in practice.
So I guess the model has been implemented in some CRM systems, or
yeah. So the model, the implementation of the model itself, that like we have an R server, and where actually the model is scheduled every day. The model is running, and then you're generating some results out, and then these results are basically going into our CRM in our campaigning system, and there accordingly there are some campaigns which are generated automatically, and there are certain probability which also goes into our safe desk where we usually even call the customers.
Okay. So one question from Lucas was, how was the ratio between data points and model parameters?
I mean, it's again the curse of we have the curse of dimensionality over there. So it was, I mean, we had, I don't know, some data is quite enough. Then dimension is also, I think we have around, I don't know, 40 parameters and for around 500,000 data points. So it's really not that. We have the problem was the curse of dimensionality. So that's why actually we use the hyperparameter optimization to optimize that.
Okay. So one question from Roland is there a significant advantage in predicting churn using neural networks over XGBoost?
Yeah, this is the thing was that I haven't done very thorough analysis on that, but if you look at the research paper on my slide, what I mentioned, where they were using actually the benchmark comparison. So they were actually there. You can see that the tree methods are better than neural network basically, but I didn't actually found it like that in our example. We actually use XGBoost as well. We did hyperparameter optimization for XGBoost as well. We did random forest as well. The thing what we find out for neural network is that it has got a very smooth distribution of probabilities. So if you look at the results coming out from XGBoost, you kind of have these, missing gaps of probability. Like for example, when you try to do present the histogram of that, you're going to find some gaps in the histogram. And there were some customers, there were some individuals which did not get any, there was no decile, for example, anybody with churn probability, I don't know, 78 theoretically. But if you look at, but neural network was giving a very smooth kind of the curve was relatively smooth, very smooth actually. There were no there were no missing values in between. So this at least this is the thing what I noticed in personally. But of course, if you read research, if you read literature, if you also can go actually and look at Kaggle, 2/3 of the algorithm, the computations there are won by tree-based methods. neural networks are very good for image processing and all these kind of tasks, but where the more categorical data comes along, neural network has some kind of limitation over there. So this is what I have been reading, what I've studied. In practice yet I haven't seen that, but this is, of course, we are now comparing multiple models there as well now for ourselves.
But I mean, those kinds of categorical data, wasn't that the case for your churn data set as well? So
exactly,
how
yeah.
did the neural network then deal with that kind of data?
Neural network does deal with this kind of data, but in practice, when we look at the performance history of different algorithms used on different set of problems, then it turned out to be that the tree-based methods are relatively better. 2/3 of the computations are won with neural network, tree-based method. It doesn't mean that neural network cannot handle it. Neural network can handle it, of course, it's handling it, but the practice shows that as I keep on repeating, that the tree-based methods behave better. But in our case, we didn't actually notice that. Originally, as I mentioned, we started with tree-based methods, but somehow we were not able to go far with that because of these couple of things that we figured out in between. Maybe they could be changed actually. Yes.
Okay, so one other question was, I honestly forgot the name, but how frequent do you train the model and how frequently do you score the model?
So scoring is basically normally done on I don't know, weekly basis or something. Scoring is something you can do. That training is something that you really have to continuously look after 2 or 3 months of 2 or 3 months of the history. So you have an out of sample projections. So we predict something today, and then you see in 3 months, 4 months, 6 months, 7 months, is this customer churn or not? And then you can also see that whether this trend of your algorithm is stable or not. For example, if in June to July it was able to predict 30%, the next 3 months should also be able to predict at least 30%, but should not go down. So it's something that you actually develop over years. This is not really that you can do in months, basically.
Mm-hmm. So another question, I don't know if you want to give this away, but what was the imbalance ratio?
Yeah, as I mentioned already, this is not a problem. This in telecom in general, you have only 2% of the churn.
2%. Okay.
Only 2% is the churn, so you can actually see how imbalanced the data is. Okay,
and the overfitting was prevented by using SMOTE and oversampling. We have this already. Yeah. Another question was, in our package for Bayesian optimization, there are plenty, so I'm not going into this. And last question from Lucas, are the agents receiving the information from Lime and or Shapley?
Shapley, not Lime anymore. We're working on Shapley now.
Okay, so I think, I'm not sure if I got all the questions, but I think there were all plenty of them. Maybe, again, a big applause, a virtual applause to Vaseev. I'm just using my reaction here. And yes, thanks for taking your time. Also, thanks to Felix for his great talk. I would really like to, if you like this, please also give us feedback on the Meetup page. So if we should continue in this kind of mode. Honestly, currently there are no other options, so unfortunately, but I hope to see you soon also in physics, also in the real world, not only virtual. But for the time being, we will plan only online meetups. So if you have an interesting topic, if you know some interesting speakers, please come to us. Please let us know. We are organizing the meetups on a monthly basis. I mean, the bad thing about Corona is, okay, we cannot see each other for real, but the good thing is maybe we are also talking to some international speakers, so maybe for next time we could also get some speakers from the US. So here we are also in close contact with our studio. But in any case, I hope you liked it. Please like it on, I don't know, I'm no social media expert, but on Facebook and all the channels there are. Also a little, again, the little advertisement from my side is the small course we developed thanks to Corona. So we had some time I'm sorry, this is not the right link here, but if you want to do some free art course, please just do it. It's online, it's for free. And yes, please enjoy the evening. Hope to see you next time. Everything is on YouTube, I hope this works. And please also give us some honest and plenty feedback so that next time we can make it better. So see you all soon. Have a good time.
Thank you very much. Thanks a lot for the invite as well.
Bye-bye.
Thank you. Bye-bye.
Bye-bye. Yes.